All right, good morning, class. Let's go over some of these problems that you had to work on last class. So let's see. Number 5 was a problem where you had to look at the components of each vector, find the x components and the y components using cosine and sine, sum up the x components, and then use the x components and the y components to make a right triangle, and then use the Pythagorean theorem to solve with that. It's fairly similar to this example problem too. So if you follow the steps there, that's how you would solve that one. For number 6, again, you have to find the x and y components, so same thing. And then it talks about drawing a free body diagram. We haven't talked about that, but the forces on this box, well, there'd be gravity straight down, and then there'd be the tension from each of these ropes. So basically, how many forces is that? It's 3. And so those be the forces involved. And so gravity is just a straight y force. It's in the negative direction. And that's mass times acceleration, or the mass of the object, 3.2 kilograms times the acceleration, which is 9.8 meters per second squared. That gets you the force there. And then you can figure out, you have these forces here that are given. For number 7, you're walking north, and then you're walking east until your displacement is 10 kilometers. So that means your resultant, or your hypotenuse, is 10 kilometers. So you have to figure out, if this is 8, and this you don't know, but this is 10, how far is this east part? So it's a Pythagorean theorem problem. For number 8, think about, you've got a swing kind of where the webbing of my fingers is, and then you've got 2 ropes hanging down, each at an angle of 13 degrees. You're given the tension, and you want to figure out what the force is on the 2 ropes. So let's see, that looks something like this. Since both ropes are like this, the horizontal part of the left rope and the horizontal part of the right rope cancel out, and so you're just left with the vertical parts. It's actually a fairly simple problem. For 9, could a vector ever be shorter than one of its components? Well, think about my thumb and my index finger being my thumb being one of the legs. Let's imagine this red line is the other leg, and then my finger is the hypotenuse. It's basically asking, could my finger ever be shorter than any of these other 2 parts of a right triangle? So think about that. And let's see, if the x-axis is east, for what range of angles is the x component positive? So the x-axis is east, and when is that positive? Well, anywhere in here, so that's 0 from 0 to 90. And then there's also these angles down here. So that's 360 to, I'll let you figure out what's right here. Think about that unit circle. All right, so that's the classwork, homework in a nutshell. There's a few more things here. Again, adding together vectors, so you have to find components. Finding the sum of these vectors. So again, this is using components, practicing with components. And let's see if I can show you a quick example how to do that. So let's see. Here's 11. Oh, that's number 1. My bad. Okay. Yeah, I don't think I have a copy of that online. Okay, there you go.